This is Michael doing stage 3 of standard 2. The problem says in the diagram, point A and B are on the unit circle and O is the origin. A asks, explain why the central angle BOA is labeled alpha minus beta. So, for part A, the xy coordinates for A is cosine alpha and cosine alpha and sine alpha, as you can see here. And this makes the angle created from 0, 0 and to the point cosine alpha and cosine alpha and sine alpha alpha. So because of the relationship between cosine alpha to 0 and sine alpha to 0, we can make the assumption that from here to here it's going to be alpha. The angle is going to be alpha. The same goes for B. Cosine beta minus 0, sine beta minus 0. So this angle right here is going to be, the angle measurement for this is going to be beta. And so the central angle BOA, so this is just going to be alpha, the big angle measurement, minus beta, the small angle measurement, as is seen here. So that is my reasoning for the simplification. And now moving on to B, it says obtain a formula for cosine alpha minus beta by applying the dot product formula and simplify. Explain the reasoning in your simplification. So here we're asked to use the dot product to simplify cosine alpha minus beta. So from many problems ago, we learned the dot product formula, which is cosine theta is dot product of v and u, those are vectors, v and u, over the absolute value of v times the absolute value of u. So we're just going to incorporate this into this. So what we're going to do is theta is going to be alpha minus beta. And the dot product between the vector OA and OB is going to be cosine alpha times cosine beta plus cosine alpha, sine alpha times sine beta. This is the dot product between OA and OB for their values are right here, their x and y values. And for their absolute value of V, which is going to be OA in this instance, it's just going to be 1. Because this thing is on a unit circle and its radius is 1. So absolute value 1. And same goes for V. U and V are both 1, their absolute value. So now my reasoning in my simplification is that. And so now on to part C. So part C asks, by replacing beta by negative beta in my formula and simplifying, obtain a similar formula for cosine alpha plus beta. Explain the reasoning in your simplification and why the new formula is familiar. So for part C here, what we're going to do is we're going to use the equation that we found in part B. So by replacing B, so part C is basically replacing beta with negative beta and give us the new equation cosine. So this is basically cosine alpha minus negative beta, which can be simplified down to cosine alpha plus beta. And over here, this equation is going to be the same as from the before. So we're just gonna simplify this real quick. So dot product cosine alpha times cosine is going to be negative beta plus sine negative beta times sine alpha. And this can be simplified even more down to this, which is cosine alpha times cosine beta minus sine beta times sine alpha. And this can be achieved because from previous problems we had learned three identities, which is cosine alpha is equal to cosine negative theta, and sine theta is equal to negative sine theta. So it just makes the equation simpler and just cleaner down here. So this is going to be my equation for when cosine is alpha plus beta. Why this equation might seem familiar is from just a few problems ago. There's the same identity as this one, but we used it by using the rectangle and the acute triangles to try to prove this theorem or equation or Y identity. But now, after using the unit circle to prove this problem, we have confirmed that this equation and this equation is we can use them for all situations of theta.